Everyone, in this lecture, we are going to discuss the priority queue. So what is a priority queue? As the name implies, it's a type of queue, but it's different than the normal queue. The normal queue follows the FIFO approach, first in, first out. The first element to be added is the first element to be removed. But with the priority queue, it's a different approach. It's based on the highest priority. A priority queue is a tree-based data structure, as you can see here. So it is a tree, it is a binary heap that should satisfy a heap of invariants or property. As you can see, there is a condition. The parents should always have the smallest number. So as you can see, 2 is less than 3, the left child, and also less than 6. The same thing for here, the subtree. 3 is less than 8 and 10. So we call this a min heap. Now we can also have the max heap in which the parent has the highest elements. As you can see, 15 is higher than 10 and higher than the right child, 12. And the same thing for the subtrees. Now let's go to the whiteboard and then have an example how we add, how we insert elements into priority queue and how we remove elements. So let's say we have values in the array, some values in the array. So let's pick like random numbers. Let's say we have 4, we have 9, we have 7, we have 3, we have 8, and then we have 2. So 2, 4, 6 elements. So these elements from array, we want to add them to insert them into priority queue. So we start with the root. The root is the node on top of the tree. So we start with 4. Remember, it's a tree that has 2 children. Every parent has 2 children. So I'm going to put 9 here and always make sure that the heap property, which is the parent, should always be the smallest number. So here 4 is less than 9, so we are fine. Now number 7, we are still following or satisfying the mean property. Now what about if we add 3? Now here we are not satisfying the heap property because 9 is not less than 3, so I have to swap them. I'm going to put 9 here and then 3 here. Okay, now I'm going to 8. So 8, the heap property is satisfied. So I'm going to put here 8. Then finally 2. Now here I have to swap 7 and 2. 7 and 2. So 2 will be the parents and 7 will be the left child. And also make sure that 2 you swap it with 4 because always the smallest number should be the parents. So I'm going to swap 4 with 2. So 2 will be here and then 4 will be here. Now, what is the priority queue? What is the state of the priority queue after inserting this element? We start from level 0, 2, and then we go from left to right, 3, 4, and then level number 2, the first one is level 0, level 1, level 2, always from left to right, 9, 8, and 7. So this is the priority queue after insertion. Now, if you want to add another element, if that element is bigger than 4, there will be no change. For example, if you want to add number 12, there will be no problem. Now, what about if you want to add number 1? So if I want to add number 1, I have to swap it with number 4. So 4 and the 1 will be here. And then swap 1 and 2. So I will swap 2 and 1. So 1 will be here. And then, so 1 will be here. 1, 1, and then 2 will be here. So now the new states of the priority queue will be the following. Will be 1, 3, 2 from left to right, 3, 2, and then 9, 8, 7, 4. Now the next question is, what's going to happen if I remove? So if I want to remove, we usually remove the number with the highest priority. In this case, it's 1, the roots. So to remove the 1, we need to get the last number in the tree, which is number 4. So I'm going to put 4, swap it with 1. So 4 will be here. And then it will bubble down until it finds its right place. So I'm going to swap it with 2. Why? Because 2 is the smallest of this subtree. So I'm going to swap 4 and 2. So 2 will be here, and then 4 will be here. Now there is no more swapping required because it satisfies the heap property. Now what about if you want to remove another element? So the last one is 7. I'm going to swap it with 2. So I'm going to remove 2 and then put 7 here because 7 is the last one in the tree. And then to make sure we are satisfying the heap property or invariance, so 3 and 7 will be swapped. So 7 will be here, and 3 will be the roots. So 7 will be where 3 is. Okay, is there any change to be made? No. So what is the final state of the priority queue? It will be after 2 removals, after removing 2 elements. So we're going to have 3, 3, 4, 9, and 8. All right, so that's how we insert elements into priority queue. This is how we remove elements. All right. Now, finally, what about if I want to remove a specific number? Not the smallest one, not the one with the highest priority, not the roots. So if I want, for example, to remove number 4, how can I remove number 4? Well, to remove number 4, again, you get the last number, 8, and then you swap it with number 4. So here we're going to have number 4 will be 8. That's it. Now there is no more swapping required. Okay. Let me give another example just to make sure. So just especially when you're removing specific elements. So let's say we have the following binary heap. Let's say we have 2, and we have 6 here, we have 5, then we have, let's say, 9. Remember, the heap property should always be satisfied. 7, and then here, let's say, have 12, and then here we have 10. Okay, let's say this is an example. Now, how do we remove number 5? So to remove number 5, now we know how to remove number 2, right? We get the last number 10, we swap it with 2, and then it's going to bubble down until it finds the right place. Now, what about if you want to remove a specific number? So if we want to remove number 5, we always get the last one, 10, and then swap it. So now I'm removing 5, so I'm going to have 10 here. And then there is no swapping to be done, so that's going to be the final, okay, final steps. So let's say I want to remove number 6. So if you want to number 6, the last one is number 12. So I'm going to put number 12 here. So I'm going to put number 12 with 6 because I'm removing number 6. So 12 would be here. Now here we are not satisfying the binary heap property. So 7 should be swapped with 12. So I'm going to put 7 here and then number 12 here. So what is the final, the state of the project queue after all these changes? It will be 2, 9, I'm sorry, it will be 7. We go from left to right. So 7, 10, 9, and 12. I hope you find this video useful. If you still have questions, please do not hesitate to ask and let me know. Thank you.